Okay, so we're doing, this is our lesson 3, for our scale drawing and design unit. We're talking in Math 20-3. We're talking about components parts diagrams. Now, components part diagram shows all of the individual components of the object. So for example, we have a component parts diagram of this mountain bike, and as you can see that basically we've got labels on all of the different pieces, identifying what they are so that people can look at the whole thing and see all the pieces that make it up. With a components parts, you need to have all of those pieces. Now when we sketch a component parts diagram of a 3D object, we have to use a scale to accurately draw each part. In other words, we can't just guess or freehand it. We actually have to use a ruler. So you all have a ruler at home, right? So we're going to draw a components parts diagram for a planter using a scale 1 to 10. So remember, that means our scale factor is 1/10, which is equal to 0.1. So when we sketch this planter, we're going to draw all the pieces, and we're going to draw them in that to scale. Okay, so if this is our planter, let's figure out what all those measurements are. 40 inches, would, with the scale factor, we would times it by 0.1, and we would get 4 inches. We times our 12 inches by 0.1, and we get 1.2 inches. We times our 15 inches by 0.1, and we get 1.5 inches. We times our 30 by 0.1, and we get 3 inches. And we times 18 inches by 0.1, and we get 1.8 inches. We're going to need those measurements for when we are actually doing our scale components parts diagram. Now we can explode this piece, and we're going to talk about exploded diagrams. It might be easier to do it that way. And again, we use a ruler. So what you're going to do, I'm going to start with the bottom. So if I have 4 inches for my bottom, 1, 2, 3, 4, and then that is the top of a side piece, and the bottom of the side piece is 3 inches. So I have to shift it over a little. And these pieces on the slant are 1.2 inches, and on the slant here, 1.2 inches. I'm going to label it. You'll be able to get, as I've said, you'll be able to get this a lot better than me because you're working on paper. So this is the side, and we have 2 of them. So we're going to note that we have 2 sides. The top of the side, this is the front and back sides. So the top is 4 inches, and the bottom is 3 inches. And the angled side going up is 1.2 inches. Okay, now we have our left and right sides. And we again have 2 of them. So our left and right sides, using our ruler, our bottom is 1.5 inches. And our top is 1.8 inches. And I'm unfortunately eyeballing it. And our sides are 1.2. Our slant heights. Okay, so they're a little smaller. It's deeper, or it's wider than it is deep. So looking at our measurements, we have 1.2 inches we have 1.8 inches, and we have 1.5 inches at the bottom. We have 2 of those. And then we have the bottom of the planter. And looking at the bottom, we only have 1 of those. And it is 3 inches by 1.5. Now this one's actually the easiest one to do because it is a rectangle. So 3 inches by 1.5 and 1.5. I like that my ruler tells me when it's at 90 degrees. It's a handy function, and 0 degrees. So the bottom is there. I'll get rid of my ruler. So looking at the bottom, it is 3 inches by 1.5 inches. So that's a component parts diagram. It's also an exploded view diagram because it's when we're going to talk a little on the next page about exploded view diagrams. And an exploded view diagram, except that we would actually draw 2 fronts and back sides, and we would draw 2 left and right sides, so we would have all 5 pieces. We're just drawing each of the component parts, and we're indicating that there's doubling. So component parts, you can indicate the double parts, okay? For an exploded view diagram, it's a little bit different. It shows, I want a different colored pen. It shows the components of an object and how they fit together. You probably have seen these with IKEA furniture. So in a diagram, it's a diagram that shows you how to construct an object. And you might see such a diagram in the instructions for furniture that you assemble from a kit, or a model or a toy that needs assembling. So, think of the assembly instructions for IKEA furniture or for like Lego sets, right? And they'll show you a picture of how you put things together. This is one for a table. So we have all the pieces. It shows you where the fastener holes are. It shows you where the leg assemblies are and the sides and the glue blocks. So basically it's like these are all the parts. It gives you some of your measurements. It probably would give you all these parts, and then you would compose them and put them together. So you would interpret that exploded view, and you would decide how they go together. Now, to draw an exploded view, you're basically taking all the pieces and you're expanding it out. So looking at this diagram, I have this shelving unit before, and we want to use a scale of 1 to 5. So the big tall, so 1 to 5 scale factor is 1 over 5, right? 1 divided by 5, I believe, I'm going to do it on the calculator, but just in case, I believe it's 0.2, but I would rather be sure. Yep. It's 0.2. So let's figure out our measurements. So this would be times 0.2. So 60 times 0.2 is 12 centimeters. This is really big, what we're going to draw. 35 centimeters so 35 times 0.2 is 7 centimeters. And 38 times 2, or 0.2, sorry, is 7.6 centimeters. Now, if the whole thing is 60, that means half is 30, but let's take this and let's sketch it out. Now, I'm going to scroll mine up because of the space involved, and I'm going to get my ruler out. Yikes. So we have, there it is. We have the top, and we know that the front is 7.6 centimeters. So 1, 2, 3, 4, 5, 6, 7.6. Okay. And the depth is 7. So if I'm sketching the depth of that like so, I want 7 centimeters. 1, 2, 3, 4, 5, 6, 7. I'm going to try and keep that same angle. Okay. And I'm going to draw 1, 2, 3, 4, 5, 6, 7. So this is how our top goes. I think I screwed my angle up a little bit. Okay. So this is the top, which is 7.6 centimeters. And the side here is 35. No, I've got to do the scale. I'm sorry. 7.6 centimeters by 7 centimeters. So that's the top, right? And then I have a side. And from my unit, this has to be 12 cent. I don't know if it can fit on this page. So let's see. So 12 centimeters tall for this piece. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just barely, right? And then, oops. You're going, Mrs. Finley. It'd be so much easier on paper. And then our piece to the back is 7 centimeters long. Uh-oh. Let's get it back. Turn that eraser off. Okay. 1, 2, 3, 4, 5, 6, 7. I'm going to have to overlap just because of the space of this, right? And then 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then, whew, so this can be kind of complicated. This might be something that when you're doing it, that you choose to do it on a piece of loose leaf, because there's not a lot of room here, right? So you can see what I'm doing is I'm sketching the top and then the side. And then I'm going to have another piece that looks like this one in the middle here. 1, 2, 3, 4, 5, 6, 7 with a front of 7.6. 2, 3, 4, 5, 6, 7.6. And a side of 7. Right. I'll know when because I can do like 0. So I'll just match it up. Right, like this. So this is another 7.6 centimeters and 7 centimeters. This one here, the whole side length was 12 centimeters and the depth was 7 centimeters. I've got another piece like that, another at the bottom like these. And it kind of just shows how they fit together. 1, 2, 3, 4, 5, 6, 7.6, right? Okay. And then about 30. Oh, whatever. Okay. 1, 2. Okay. And then another. And I'm going to finish it up with my 0. I got pretty good at eyeballing that one. And then I've got another panel that I can't quite fit, but it would be like this panel here that would go on the outside. And it's just really because of the space here. I can't really fit it. So, like I said, you might want to do it on another piece of paper, but you would have another panel on that side just to kind of show how that expanded out. So that's a task for you. So sketching that other panel. Basically, it's just taking it and saying, okay, what if I blew it apart? Now we also, I'm assuming that there's a back piece. So there would be this back piece as well. So the two pieces that I didn't sketch due to space is the back and the side. And those as well would be incorporated in part of your drawing. You can overlap, like if you notice I've overlapped here at this place here, and that's fine. We're more getting a sense of it for how it goes together. But the idea, it literally is, exploded view is literally exploded, as if you took the piece and you blew it up. So have you ever seen those movies where they blow something up and for a moment everything kind of hangs in the space before it goes boom? That's kind of what you're doing. You're that moment before it goes boom. Okay? It's kind of fun to do. These ones I would suggest, instead of doing them in your booklet, there might not be enough space. So what you might want to do is have a piece of loose leaf or a piece of white paper where you can do these, where you have more room. Don't forget about your scale factor, right? So here it has a scale factor is 1/15. You're going to get that number and you're basically going to times everything by that, right? So this would be 0.06 repeating. So you would times this by 0.06 repeating, and you would get 4 centimeters. Same thing here, 0.06 repeating, get your value there. That's 60 again, so you'd get the same number. So keep that in mind. For this, if it doesn't have measurements, measure what it actually is and just use those measurements so that you can stay proportional. Okay? But it's kind of a fun little drawing exercise. It's taking a look at these things and seeing what happens when you take the pieces and spread them out. There's a real good value to them. In terms of things like furniture building, IKEA has really mastered the art of it. And it's great guidance for people who who have never built something before. If they use an exploded view diagram, they can certainly use that to kind of figure out how things fit together. Okay, and usually they'll have more detail than what we have. If you look at the original thing here, it has things like where the fasteners go in, the glue blocks. It has information like that so that people know how it exactly fits together. And IKEA diagrams will be even more detailed. So those are exploded view diagrams and component part diagrams. So you have a couple examples to do here, and you have a worksheet to work on.